The treatment of cancer is now going through a fundamental change, and patients with advanced inoperable forms of the disease are experiencing dramatic improvements in their health as a result of a new approach. The key is genetics. There are 20,000 human genes, and reading their data has made it possible to identify the cause of cancer in each patient and the most suitable course of treatment. So how will this new therapy change the future of medicine? Bring you a look at the latest developments in this field. Here we are at the National Cancer Center for this special report.
Japan is a world leader in cutting-edge medical technology and healthcare services. Join us as we explore medical frontiers. Koichi Goto is an oncologist specializing in lung cancer. He is helping many patients with a new approach to treatment focusing on genes. He wanted to overcome the limitations of conventional cancer medications.
With conventional drugs, the response rate shows that only 30% of lung cancer patients' tumors shrink in size. That's how limited the effects are.
Cancer results when normal cells undergo certain changes. The cause lies in genes. One human cell contains more than 20,000 genes. Factors including ultraviolet rays and smoking can cause damage to genes and lead to abnormalities such as mutations. Such genes produce a large amount of abnormal proteins, which can cause cancer. Recent technological advances have made it possible to analyze cancer patients' genes in detail. The type of cancer a person develops depends on which genes are affected. For example, each affected gene produces a different type of abnormal protein that leads to a different type of lung cancer. Conventional cancer drugs aren't formulated to address these differences. They work only if they happen to be effective against a patient's particular type of cancer. Goto has been leading an effort in Japan to pinpoint which genes are affected in each patient. He believes this will allow for more effective targeting with drugs through what's known as precision medicine. First, doctors remove several cancerous cells from a patient's lung. The cells are then sent to a lab where genes are extracted from the sample. Then, they decipher the genetic information. Genes contain 4 chemicals: adenine, thymine, guanine, and cytosine. They're called bases and are linked together like a chain. Sometimes, damage to a gene can cause a mutation in one or more of the bases. At the lab, technicians compare each patient's genetic data to that of a healthy person and look for abnormalities.
You can see in this column there are several T's instead of A's.
At the bottom is the normal genetic sequence. The patient's data appears above. In the patient's data, a T for thymine appears in several places where there should be an A for adenine. This indicates a mutation. With this information, doctors can identify the abnormal protein specific to a patient's type of lung cancer. And they can prescribe what's known as a molecular targeted drug. Such drugs are designed to work on the specific protein to keep the cancer from advancing. This patient was diagnosed with lung cancer 5 years ago. By the time it was detected, the cancer had progressed so far it was no longer treatable with surgery.
I had been thinking it was cancer. But still, I was shocked when I saw the image with my own eyes.
He began receiving conventional chemotherapy, but over time it became less effective and his tumor began growing again. At his doctor's urging, he underwent genetic testing and then enrolled in a clinical trial for the new treatment. Before the trial, his tumor had measured 3.6 centimeters. 9 months later, it had shrunk to less than half that size. The man has experienced no major side effects from the medications and is now back to his normal daily routine.
I'm told the treatment dramatically increases survival, so I'm very glad. My wife is happy too.
Conventional drugs shrink tumors by half in less than a third of patients with advanced lung cancer. With the new treatment, each patient is given a drug that works against a specific abnormality. On average, tumors shrink in about 70% of cases. In addition to being highly effective, experts say the treatment has few side effects. The Japanese government has given the green light to treating lung cancer with precision medicine, and major hospitals are starting to introduce it.
Thank you so much for your time today.
Pleased to meet you.
Doctor, what are some of the key advantages then of precision medicine over general chemotherapy?
Conventional cancer drugs focus on the rampant proliferation of cells and are designed to inhibit it. Cancerous cells proliferate at an astonishing rate, prompting the drugs to attack them. But rapid proliferation also occurs in cells at the root of a hair, for example, or the mucous membrane of the digestive canal. In short, conventional drugs attack not just cancer cells, but also healthy tissues. But precision medicine targets only genetic abnormalities. It dramatically reduces attacks on normal cells. In other words, it can target abnormal cells with pinpoint accuracy. So, it's far more effective for treating cancer than conventional drugs, minimizes harm to normal cells, and is significantly less toxic.
And doctor, in terms of comparing it to something like conventional surgery or radiation, is precision medicine a better option than both of these?
Patients in the early stages of cancer should have surgery with the aim of curing the disease. I don't think molecular targeted drugs and precision medicine are necessary for all patients. It's still a challenge to completely get rid of cancer using molecular targeted drugs and precision medicine. The purpose is to bring cancer under control and extend a patient's life. So if the cancer is still at a stage where a complete cure is possible, patients should opt for surgery or radiation.
So, Dr. Goto, can you find these genetic alterations in every single person?
It's not that genetic analysis can turn up genetic abnormalities in every patient. I'd say some form of abnormality can be found in about half of all lung cancer patients, but as for the other half, we haven't found any genetic abnormalities. I believe that future studies will confirm that other types of genetic abnormalities are occurring in these patients. But for now, I don't recommend molecular targeted treatment for people without confirmed abnormalities. Instead, they should opt for approaches such as conventional cancer drugs or immunotherapy.
To promote the advance of precision medicine, Goto launched a large-scale research project called SCRUM Japan in collaboration with other cancer experts. Medical institutions across the country and 16 pharmaceutical companies are taking part. They're sharing data and conducting joint studies on various types of cancer. Takashi Kono is one of the members. Before joining SCRUM, he began researching genetic abnormalities in lung cancer. As recently as 2010, only 3 genetic abnormalities were known to cause lung cancer. So, for many patients, genetic analysis wasn't an effective means of determining what kinds of abnormalities they had. Kono spent 2 years closely examining data from 300 such people. He discovered that another abnormality in a gene called RET can cause lung cancer. He knew that the same abnormality had been found in thyroid cancer patients, and that a drug to treat it was available. Traditionally, cancer drugs have been selected based on the organ that's affected. That's because the conventional wisdom was that the shape and characteristics of cancer vary depending on where it occurs. But recent studies have shown that one type of genetic abnormality can cause cancer in different organs. This convinced Kono that the same drugs could be used for cancers arising from the same genetic abnormalities, regardless of where they occur. Using genetic data gathered by SCRUM, he began a clinical study on lung cancer patients with a drug typically used to treat the RET gene in thyroid cancer. This image shows the lung of one participant. The person's tumor had measured about 7 centimeters. 2 months later, it had shrunk to less than 5 centimeters. About half of the study's 19 participants showed signs of improvement.
I believe it will become common to use the same drug for cancer in different organs if scientific evidence suggests it could work, as it did for us. Up until now, drugs have been chosen depending on which organ is affected. But we will see a gradual shift to therapy based on genetic abnormalities.
Dr. Goto, how is the genetic analysis, how is it actually affecting the development of different drugs?
Genetic analysis has turned up the same abnormalities in, for example, lung, large bowel, and prostate cancer. The discovery has prompted us to conduct clinical studies and develop treatment not just for lung cancer, but for all cancers caused by the same genetic change.
So, Dr. Goto, is precision medicine, is it effective, just as effective over the long term? Is it always effective?
Molecular targeted drugs are effective, but their effects don't last forever. There's a limit. Generally speaking, the drugs that are currently available work for about a year. That's about the time when a different abnormality occurs in cancerous cells, making a drug less effective. If we take CT and other scans, they may show that a tumor has grown bigger. But by adding a drug targeting the new abnormality, we might be able to shrink the cancer again. So we have to conduct genetic analysis when the effectiveness of a drug begins to decline. By repeating this process, we can curb the growth of cancer for a long time.
Analyzing human genes involves the processing of a huge amount of information. Researchers at Scrum Japan have been looking at an advanced technology to help make the job more manageable. It's artificial intelligence. Experts believe AI will be able to come up with treatment plans for humans in the future. More than 100,000 scholarly papers are published on cancer each year. They can provide new information, such as the characteristics of previously unknown genetic abnormalities, or which drug is effective against which abnormality. Along with scholarly papers, researchers plan to feed AI information on things like medications and clinical trials. Then, they'll compare all of this data against individual patients' genetic data to find the optimal treatment.
It's just about impossible for doctors specializing in cancer to read every paper and remember the contents. It would be much faster for computers to do that, using natural language processing and artificial intelligence technology. Also, parallel and faster processing can shorten the time needed to find the best possible treatment.
The team hopes to begin using AI-assisted diagnosis at Japanese medical institutions within 3 years.
So can you explain how artificial intelligence, Japan is so advanced in artificial intelligence, how it's also affecting precision medicine?
In the future, if we feed AI with samples, I think it will be able to conduct genetic analysis and propose treatment plans, including proposals about which drugs to use. But the application of AI in precision medicine is still at a very early stage. In fact, we began using AI only a few months ago. As a first step, we are aiming for accurate genetic analysis with AI.
I mean, it's such an exciting time to be involved in this, amazingly progressive field.
Over 6,000 lung cancer patients have undergone genetic analysis. Scrum Japan has also had patients with cancer in other digestive organs undergo analysis. Altogether, that's more than 10,000 people. We hope to bring in a new era of cancer treatment using big data.
Dr. Godo, in terms of data sharing, not just domestically, but worldwide, or with the US or whether it be Europe, what are the actual possibilities of some sort of a joint collaboration?
We'd like to be able to compare and merge our big data with big data from Europe and the US and create a global database. It would contain clinical data and genome information from all of those places. We're eager to swiftly develop new treatments and verify their efficacy in collaboration with our peers from Europe and the US. Through these efforts, we want to get closer to achieving our primary goal of delivering effective medicines to patients as soon as possible.
Dr. Godo, thank you so much for your time today. As a result of genetic analysis, cancer treatment has entered a new phase, but research is still in its early stages, and there are many patients who are not yet able to experience its benefits. To help them, an extensive analysis of different types of cancer genes is necessary. And as data on cancer genes accumulates, it increases in value. Many are hoping that this wealth of information will be shared with different organizations and countries to help advance cancer treatment even further. A strong immune system is essential in helping to prevent cancer. And today on the program, we're going to be introducing some recipes which can help boost our immune system. And today on the program, we're joined by a very special guest, Dr. Watayo, who is an oncologist. Thank you so much for your time today.
Nice to meet you.
So what can we do to boost our immune system?
Meals are extremely important. I would say that meals determine 70% of our immune strength. It's important to boost immunity with diet. More and more evidence points to the importance of eating vegetables and fruits. They're rich in antioxidants, which can remove a toxin called active oxygen, so they can help protect our health. Fresh vegetables and fruits are a good source of antioxidants, especially colorful ones like carrots, tomatoes, and apples.
So, Dr. Watayo, what recipes are we going to be doing today?
I'll show you how to make juice and soup with a lot of fresh vegetables and fruits.
So, which juice are we going to start with?
First, we'll make a juice containing apple, lemon, and tomato that's extremely rich in antioxidants. Peeling all the skin eliminates a lot of the polyphenols, so leave that on as much as possible. Polyphenols in apples, lycopene in tomatoes, and eriocitrin in lemons all have powerful antioxidant properties.
So why are we using a slow juicer here and not, for example, a regular juicer?
High-speed juicers destroy cells, causing their components to break down. But with slow juicers, the cells of fruits and vegetables remain intact. I recommend this type of juicer. I call juice made this way antioxidant juice.
Smells great too.
Yeah.
So it's probably really good for people who don't like the taste of tomato, because you've got the lovely sweetness of the apple.
Next, we'll make a juice that strengthens the stomach and boosts the immune system. Which ingredients do you think we'll use?
Well, I know that cabbage juice has been used for hundreds of years to protect against stomach ulcers. So I would say this one.
Right. You've got to have a good stomach for healthy eating. Cabbage contains cabbagin, or vitamin U, which strengthens the stomach mucosae. It's been known as a remedy for stomach ulcers from olden times. Carrots are extremely rich in carotene and vitamin A. So they boost immunity and help prevent diseases such as cancer.
It's just not as bad as I thought it was going to be. So this is the last one here.
Yeah.
Doctor, what is this one good for?
Our last juice is packed with minerals to help intestinal activity. Broccoli is high in chlorophyll, so it repairs damaged cells. In fact, broccoli is so effective against cancer that it's sometimes called cancer medicine.
And what about komatsuna? Because komatsuna is like a Japanese spinach. If we don't have komatsuna, what else could we use?
You can use kale or spinach, or other dark leafy vegetables. Kiwi is a good source of vitamin C and minerals. So this juice keeps you healthy. How is it?
Okay, it's the very first time I've ever had broccoli in a juice, and it's actually really good. Yeah, very refreshing. So how much juice should we be drinking every single day?
I'd recommend drinking 300 milliliters every day and 700 milliliters for preventing cancer.
So what have we got next?
Soup is smooth and easy to eat. Also, both the liquid and solid ingredients are nutritious. So it's full of benefits and very good for the body. We'll make pumpkin and shiitake mushroom soup. Pumpkins are very nutritious. They're packed with vitamin A and vitamin C. Also dietary fiber and carotene. Carotene is easily dissolved in fat, which enhances its absorption. So it's more effective when cooked with oil. Shiitake mushrooms contain a lot of beta-glucan, which also boosts immunity. People don't tend to eat a lot of them, but they're a very effective food item. You can absorb the nutrients effectively if you cook them slowly and drink the liquid as well.
So why are we putting a little bit of ginger and a little bit of shallots on the soup?
Ginger is high in gingerol, which improves blood circulation. Shallots, on the other hand, belong to the same family as scallions and onions. They also contain allicin, which strengthens the immune system.
Delicious. I love pumpkin. And the combination of shiitake and pumpkin, because pumpkin has a really nice natural sweetness. And it's actually a really nice idea to put a bit of grated ginger in there as well.
Next, onion soup. It's very effective for boosting immunity. Onions also contain fucoidan, a major component of seaweed. It causes damaged or even cancerous cells to shrink and destroy themselves, a phenomenon called apoptosis. So this soup is very effective against diseases, including cancer. We're talking about food today, but I'm actually a surgeon. I've done many surgeries and worked hard to cure diseases, but many are extremely hard to cure. I wondered if there was a way. In the end, I concluded that what matters most is meals. It's best to boost your immune system and resistance through food. That goes with the saying that food is medicine, so I'm promoting diets that fight disease.
Thank you so much for sharing the recipes for both the juices and the soups. And I'm so inspired to try the juices tomorrow, and especially the soups were really delicious. So thank you so much for your time today. It was a great pleasure to have you on the program.
Thank you for having me.